Hello everyone, this is the first lesson recording for IM2, February 4th, 2021. We started off with a pop quiz on vertex form, and it's going to happen in 2 minutes, so have everything ready. Have all your notes for vertex form ready, and ask any questions now before the battle starts. Okay, just kidding. This is not a pop quiz, this is just a practice quiz, but it will still be helpful for you to try this so that you can figure out what you do understand and what you do not understand and what you need to be reviewing more of. What are we doing today? We are going to be finding x-intercepts from vertex form. It's not going to be on the unit test though. And then we're also going to do some application problem on rocket launch, and hopefully we'll have some time to practice or review for the unit test. So what you should recall from last lesson is that the vertex form of a parabola quadratic equation is always going to be written in this form. Y is equal to a multiplied by parenthesis x minus h all squared plus k, where you notice that there is an inherent negative sign between x and h, and this is going to be really important to notice. Okay, do not forget that there is a negative sign built into the formula, and this is really handy because the vertex is always going to be at h comma k. So whatever the number is in that place, h and k, that's going to be my vertex. So for y is equal to 3 parenthesis x minus 2 close parenthesis squared plus 1, h in place of h is number 2. So I know that the x coordinate of the vertex is 2, and in place of k, where k is, the number is 1, so the y coordinate of vertex is 1. Also, the number in front, the a value, it determines whether the parabola is going to be vertically stretched or compressed. That means it's a skinny parabola or wider, fatter parabola, depending on what the value is. If the value is greater than 1 or less than -1, or you can also say the absolute value of a is greater than 1, then it's going to be stretched. It's going to form a skinny parabola. However, if the a value is between -1 and +1, okay, so it could be -0.5 or +0.5. Either way, it's going to form a wider, fatter parabola. If a also determines whether it's going to be opening up or down. If a is positive, it's going to be opening up. If a is negative, it's going to be opening down. Alright, so what about the x-intercepts? Before we get into that, I want to just quickly review a few square root. Okay, what is square root of 9? Hopefully you're telling me it's 3. What is square root of 16? 4, because 4 times 4 is 16. Okay, just the way 3 times 3 is 9. It's asking you, when you're taking a square root of 9 something, you're asking yourself, what number multiplies to itself twice gives that answer 9? What about square root of 32? Well, this is not a perfect square. Okay, so it's not going to be a whole number, but we can break the square root of 32 as 16 times 2, and I chose 16, not 4 and, well, I could have chosen 4 and 8 too and then gone further. Okay, or I did not choose some other number combination because I'm looking for a perfect square number to factor into. So 16 is a perfect square, and perfect squares are numbers like 4, 9, 16, 25, 36, 49, and so on. Okay, so I broke it into 16 and 2, and because square root of 16 is 4, and then you're multiplying it by root 2, so it becomes 4 root 2. Hopefully it's starting to come back to you. What about square root of 7? Well, 7 is not a perfect square, nor does it have any factors that are perfect square. So it remains as square root of 7. Now I'm going to ask you square root of -9. Okay, what does that mean? That means we're asking ourselves what number multiplied to itself twice gives negative 9 as the answer. And you might be thinking, okay, make 3. Okay, because 3 times 3 is not negative 9, it's 9, right? So that means that question mark number could not be positive 3. What about negative 3? Well, negative 3 times negative 3 is positive 9 also. So that question mark number cannot be negative 3 either. Okay, it so happens there are no real numbers that will multiply to itself twice that would give negative 9. Okay, later on you're going to learn about complex numbers, and that's pretty exciting. So for now we say there is no real number solution. Okay, so because like 3 doesn't work, negative 3 doesn't work, and there are no other numbers that will work, that will multiply to itself twice to give you negative 9 as the final answer. So that means that you cannot have a square root of any negative number. Okay, so it doesn't matter whether it's negative 9 or it's some big number or some more complicated number. Whenever you have a negative, if you ever see a square root of negative 241, then you're going to say there is no real number solution. Okay, it does not exist is what you're saying. Alright, so then let's extend that a little further. Okay, what about if I gave you this problem, x squared is equal to 9, and I asked you to solve? What does that mean? That means you're looking for the value of x that makes this equation true. Okay, what two numbers multiplies to itself twice will give 9? Well, you know that 3 times 3 is 9, so x must be equal to 3. Is that the only solution? No, there is another possibility. Negative 3 times negative 3 is also 9. Okay, that means x could be negative 3 as well. Okay, and we write this as x could be positive 3 or negative 3, so x is equal to positive or negative 3, or plus or minus 3. That's how we write it. So let me show you how I would solve this algebraically. Okay, so whenever you see something squared is equal to 9 and you want to find the value of x, what you can do is just the same as you can add the same number to both sides of the equal sign or multiply by the same number to both sides of the equal sign. You can actually take a square root of both sides of the equal sign. Okay, but when you do that, because when you're dealing with x squared, because the answer could be positive or negative, so when you're taking a square root of some variable inside here, then you need to give on the other side plus or minus symbol right there to say that it could be a positive version of the solution or negative version of the solution. And you should also know that this square root and squaring, they cancel each other out. So on the left hand side, you're just left with x is equal to, what is square root of 9? That's 3. But you have plus and minus right there. So that's how it comes about. Okay, let's try another problem. Okay, what if it was x plus 2 all squared is equal to 9? Okay, again, we are allowed to take a square root of both sides. And we do that so that to get rid of this square sign. But because we're taking a square root with some variable inside the square root symbol, we need to give on the other side plus or minus because it could be positive or negative. So as before, the square root and square cancels each other out, and you're left with x plus 2 is equal to plus or minus, what is square root of 9? That's 3. From there, we need to consider that x plus 2 could be positive 3 or x plus 2 could be negative 3. So we break it into two separate equations. Okay, so x plus 2 could be positive 3 or x plus 2 could be negative 3. So if it was x plus 2 was positive 3, then I want to find what the value of x is, so I subtract 2 from both sides. Okay, both sides of the equal sign and both sides of the equal sign. And what do I get from here? From this branch, I get this cancels out, and I have 3 minus 2 is positive 1. X is equal to positive 1. From this branch, I have negative 3 minus 2 is x is equal to negative 5. Okay, some of you think, oh, it's just going to be x is equal to positive 1 if I find and negative 1. No, it's not so. You need to do the math. Okay, don't jump into it. What about this? X minus 5 is 17. In this case, again, you're going to take a square root of both sides. And again, you're going to put plus or minus because you're taking a square root of something with a variable inside. Okay, so then in that case, what are you left with? You're left with x minus 5 squared, or x minus 5, because the square root and the square, they cancel each other. And on the right hand side, you are left with plus or minus square root of 17, because there is nothing more you can do to simplify the square root of 17, because it's not a perfect square, nor does it have any factors that are perfect square. So from there on, you do break this into two different branches, two different equations. So x minus 5 could be positive root 17, or x minus 5 could be negative root 17. From there, I want to find what x is. That means I want to get rid of this negative 5. How do I do that? I add 5 to both sides of the equal sign, likewise over here. And you're left with x is equal to 5 plus root 17 on one of the solution, and x is equal to 5 minus square root of 17. Okay, now let's try to find the x-intercept from the vertex form. Say we have this y is equal to x minus 3 all squared minus 16. This is in vertex form with a vertex of 3 and negative, comma, negative 16. And a value is just 1. That's the default number, right? Okay, so how do I find the y-intercept or x-intercept? I know that y-coordinate of x-intercept is always 0. So I use that fact and set y to be 0. And when I have this, 0 is equal to x minus 3 all squared minus 16. Now I want to be left with x minus 3 all squared and take a square root of it. So I am going to get rid of this to the other side by adding 16 to both sides. And you're left with 16 is equal to x minus 3 all squared. Then from here, I can take a square root of both sides, like so. And when I do that, I need to remember to put plus or minus, because it could be positive or negative part of the solution. So then I am left with the square root and square cancels out. So you're left with x minus 3. And square root of 16 is 4. And you have plus or minus. So x minus 3 is equal to plus or minus 4. And you do break that into two separate equations. X minus 3 is positive 4. X minus 3 is negative 4. And then subtract or add 3 to both sides, and you're left with x is equal to 7, or x is equal to negative 1. And so therefore the x-intercept is 7, 0 and negative 1, 0. Okay, this is time for you to try. Pause the video and see if you can do it yourself. Alright, I'm going to go through the answers. You use the same principle. You set the y to be equal to 0. Then from here, I am going to get rid of this plus 50, or I can actually try to bring this to the other side by adding 2 parentheses x plus 4 all squared. When I do that, this cancels out and you're just left with 2 x plus 4 all squared is equal to 50. Take a square root of both sides and you're left with x plus 4 is equal, oh no, you divide both sides by 2. Say 2 is being multiplied to 50, or 2 is being multiplied to this parenthesis. So to get rid of that, you divide and you're left with x plus 4 squared is equal to 25. And then take a square root and you get x plus 5 is equal to plus or minus 5. And you have two separate equations, and therefore, and you find your x is equal to 1 or x is equal to negative 9. So here are the two coordinates for the x-intercepts. But keep in mind that sometimes you're not going to have the x intercept